All right, so this is a quick lesson on solving systems. And I say quick because this is all stuff that you learn in Algebra 1 plus what we learned in pre-calc towards the mid of the semester. Okay, so this is solving a system. It's called a system because it's two variables with two equations. Three variables, three equations is all a system, so on and so forth. So we want to solve for where the intersection of these two lines are. So they're both lines because if you look at the exponents, they're ones, x to the first, y to the first. This is an equation of a line. Okay, so you can use substitution, elimination, graphing, which we're not going to do, matrices, which we're not going to do. So we're going to either use substitution or elimination on all four of these problems. So if you see a variable is solved for, meaning if you see a y equals or an x equals, you want to use substitution. If you don't, you want to use elimination, and you want to make sure your x's are lined up, your y's are lined up, the equal signs, and then your constant. So in this case, we're going to use elimination. So you're going to look at the equation and say, if I combine it right now, will anything eliminate? So if you combine this right now, let me make a line right here. I'd get a 6x, a 3y, and a negative 12. That's not helpful. I still have two variables. So what we're going to do is we're going to manipulate either one or both of the equations so that they are the same, they have the same coefficient on one of your variables, but they're just opposites. So like a 2x and a negative 2x, or a 7y and a negative 7y. So if you look at your x's, I can get both of my x's. Well, I can get my x's to be a 4x and a negative 4x, or I can get my y's to be a 10y and a negative 10y. It's less work to get my x's to be a 4x and a negative 4x because I'd only have to multiply my first equation by a negative 2. If I wanted to get the y's to be a 10 and a negative 10, I'd have to multiply the first equation by 2 and the second equation by 5. So we're going to stick with multiplying the first equation by negative 2. Distribute it to everything in that equation. So it becomes negative 4x minus 10y is equal to negative 8. So notice I wrote it right underneath the second equation. So now basically what I'm looking at are these two equations. And I'm going to combine them. If I combine them, a variable will eliminate, hence the name elimination. So the x's eliminate. I have negative 12y is equal to negative 24. Divide both sides by negative 12. And I get y is positive 2. So now you have the y variable, you just need the x variable. You can pick either original equation and plug the 2 in for y. So I'm going to pick this equation right here, and I'm going to plug in 2 for y right here. So I have 2x plus 5 times 2 is equal to 4, and now I'm going to solve that. 2x plus 10 is equal to 4. Subtract 10 from both sides. 2x is equal to negative 6. Divide by 2. And I get x equals negative 3. So now I want to write my answer as an ordered pair solution, x comma y, negative 3, 2. I could also use my second equation to check to make sure it's right. If I plug in negative 3 for x, I get negative 12. If I plug in 2 for y, I get minus 4, which is equal to negative 16. So I know that it's right also. Okay? All right, here's number 2. If you look at this, there's a variable solved for. This says x equals. If it says x equals or y equals, you're going to want to use substitution. So I know that this is the exact same thing as x. So anytime I see an x, instead of writing an x, I can write 2y minus 1. So I see an x right here. So what I'm going to do is I'm not going to write x here. Instead, I'm going to write 2y minus 1. All right, so let's go ahead and do that. 2 times, instead of writing x, I'm going to write 2y minus 1. And now I'm going to continue to write the rest of this equation. So minus y equals 7. So now I'm going to solve this equation that doesn't have an x and a y, it just has y's. Distribute your 2. 4y minus 2 minus y equals 7. Combine your like terms. 4y and negative 1y is 3y minus 2 equals 7. Add 2 to both sides. 3y equals 9. Divide by 3, and you get y equals 3. All right, now all I have to do is get my x value. You can go back to either equation. Since the first equation is x equals, I'm just going to use that. So I'm plugging in 3 for y once again. 2 times 3 minus 1. 6 minus 1 is 5. So I get x equals 5. I can write my answer as an ordered pair solution, x comma y. So 5 comma 3. And also, I'm going to mentally check it in the second equation. 10 minus 3 is 7. It is correct. All right, so that's Algebra 1 because I have two equations that are both linear. So in pre-calc, we did two equations with an x, both with x and y in them. but they don't have to be lines. So if you look at this, the first equation has got an x squared and a y squared, same lead coefficients, addition separating it. This is a circle. And then the second one is a line. So you can use substitution or elimination to solve. This is called non-linear system. So what I told you in class when you're doing this, if you have two quadratics, so both equations have a square in them somewhere, you're going to want to use elimination to get rid of one of your quadratics, the x squared or the y squared. If you only have one quadratic like in this, we can use substitution. So that's what I'm going to use. I want to have my linear equation be x equals or y equals. If you look at it right now, it's neither of those, but I can make a quick manipulation by adding x to both sides. And now I have y equals x minus 1, and now I can use substitution. So y is the same thing as x minus 1. Anytime I see a y, which is right here, I'm going to replace it with x minus 1. So I have x squared plus, instead of writing that y, I'm going to write x minus 1 quantity squared is equal to 25. All right, so now I have to solve this. Big thing to remember is there's no such thing as distributing a square. It is not a 2 as a multiplier in front. It's saying that I want to multiply x minus 1 by itself. So I'm going to expand this by saying that now I have x minus 1 times x minus 1 equals 25. So remember, you're expanding this to something times itself. All right, now I need to solve this, so I need to distribute that x minus 1. Sorry, I need to distribute the x to the x minus 1, so I'm going to distribute here. So I have this x squared from the original plus x times x is x squared. I have x times negative 1 is negative x, and I'm also going to do this one right here, which is also negative x. So I have negative 2x, and then I'll distribute the negative 1 here, and I have plus 1 equals 25. All right, on the left-hand side, I'm going to combine like terms. I have an x squared and an x squared, which is 2x squared, minus 2x plus 1 equals 25. So you can see that right now we have a quadratic. When solving a quadratic, recall that the first thing you want to see is if you can solve by square rooting. I can't solve this by square rooting because not only is there an x squared, but there's also an x. So I can't solve by square rooting. So now I want to see if I can solve by factoring. In order to solve by factoring, it has to be equal to 0. So in the previous step, I would have not done this right away. I would have also subtracted 25 from both sides. So now I have 2x squared minus 2x. If you subtract 25 from both sides, you get minus 24 equals 0. All right, so now I'm going to try to factor this. First thing I look for when factoring is a GCF. There is a GCF of 2 here. So I'm going to factor the 2 out of each term. I have 2 times the quantity of x squared minus x minus 12 is equal to 0. Now I'm going to factor this trinomial right here. So I'm looking for two numbers that multiply to give me negative 12 and add to give me negative 1. That's x minus 4 times x plus 3. Now I can set each factor equal to 0 and solve. I have 1, 2, 3 factors. So I have 2 equals 0, x minus 4 equals 0, and x plus 3 equals 0. So now if I go to solve each one of these equations for x, this doesn't have an x in it, so I can't solve that for x. But I can solve these two for x. I get x equals 4, and I get x equals negative 3. So now you have two x values. So now you have to get each y value that corresponds to that x value. All right, so now we're going to go ahead and plug in 4 into one of our original equations. Now looking at your original equations, the first one is a circle. The second one is a line. Now, if you plug this x value of 4 into this circle, you can get what we call extraneous solutions. It can give us solutions that aren't solutions to both equations. If you plug the x value into the line, you're not going to get extraneous solutions. You're going to get the only place where that point crosses or that line crosses the circle. So let's go ahead and use the line. I'm going to use, instead of using this right here, oops, I didn't mean to cross it off. I meant to highlight it. Instead of using the given equation right here, I'm just going to use the one I manipulated. They're equivalent. I didn't do anything wrong to it. So I'm going to plug it in there. So I'm going to do y equals the x value, which is 4 minus 1, and I get y equals 3. So my first ordered pair solution, x comma y, is 4 comma 3. Once again, you can check it in the circle. 4 squared plus 3 squared, 16 plus 9, 25. Good. I'm also going to plug in negative 3, so I have y equals negative 3 minus 1. Y equals negative 4. So I also have the ordered pair solution, x comma y, -3, -4. -3 squared is 9, plus -4 squared is 16, which is equal to 25. So there's my two solutions. If you would have used the circle, you would have gotten plus or minus right here, and you would have gotten plus or minus right here, but -3 does not work, or sorry, 4 -3 does not work in the line. If you plug in 4 for x, you do not get -3 for y. That's why we use the linear equation to check our solutions. All right, last but not least, we have two quadratics here. The first one, if you look at it, addition separating, x squared and a y squared, but they have different coefficients on them. So this is an ellipse. The second one is a circle. So both of these are quadratics. So when you have two quadratics, you want to use elimination because we can't have all of these x squareds and y squareds. So you're going to choose a variable to eliminate, looking to see which one has the least amount of work. So I can get rid of the x squareds by multiplying the second equation by -4, or I can get rid of the y squareds by multiplying the second equation by -16. My mental math is stronger with multiplying by -4. So that's what I'm going to do. I'm going to multiply the second equation by -4. All right, so I'm going to copy down my first equation because I can't squeeze it underneath there. So my first equation I'm just copying down. I didn't do this on the first one because I manipulated the first equation, not the second. And now I'm going to write my new second equation. -4x squared minus 4y squared, notice I'm distributing here, equals -64. Combine these, those cancel. 16y squared and 4y squared is 8y squared. -64 and +64 is 0. I need to divide both sides by 8 before I square root. I get y squared is equal to 0, and then square root plus or minus to get y by itself. And I get y equals plus or minus, and the square root of 0 is 0. Now remember, 0 is not positive nor negative, it's just 0, so a y value of 0. Now I need to plug 0 into either of my equations. Both are quadratic, so you can pick either one. I'm going to pick the second equation because it has smaller coefficients and I don't have to worry about them. So I have x squared plus, and I'm going to plug in y. I'm going to plug in 0 here. So 0 squared equals 16. That's x squared equals 16. Square root to solve. Don't forget to account for the positive and negative solution that both work in this equation. So you have x equals plus or minus 4. So now I have two solutions. I have 4, 0, and -4, 0. So I'm going to write it as plus or minus 4, comma 0. Once again, you can write this as 4, 0 and -4, 0. It's the same thing, but I would write my answer like this. All right, that's it for the review on solving systems. You have a homework assignment to do that looks similar to this.